This is the chapter 6 review. It does include some of 5.8. And so I'm going to go over how these problems are worked. This first one says factor this trinomial completely. Okay, so it's looking for us to put this in these parentheses, if at all possible. Okay. There's lots of ways we could go about doing this. We've talked about calculator soup. We've talked about how to use a calculator to do that. I like our guess and check. One of the methods that we used on our calculator was to take the first number and multiply it by the last number. So we would do 16 times -3. Okay, and we would do, so when we do 16 times -3, I'm getting -48. So we want something that's going to multiply to be -48. And then add to be this number in the middle, which is -8. Okay, and we talked about how we could go to our calculator and do y1 is equal to -48 over x. Y2 is equal to -48 over x plus x. And then we can look at our table and find the answer by finding in the Y2 category, we would look for -8 and we would see what two numbers are in Y1 and X. Okay, so I'm just going to do that real quick. So if I go to my graphing calculator, we're going to Y equals. Here. So again, we're doing -48 divided by x, and then we're doing -48 divided by x plus x. And then we want to go to our table, and we want to, in this Y2 category, we were looking for -8, and the two numbers are 4 and -12. These are the two numbers that multiply to -48, but add to -8. So we came up with 4 and -12. 4 and -12 were those two numbers. So when we come over here, we're going to say m plus 4, because one of the numbers is 4, and m minus 12, because that was the other number. But that's no problem, Valencia. Okay, so on our, so this is the test review for chapter 6. So if you missed some of the other lesson part, I'm going back over those problems right now, and I'm going to post this video just to make sure that you guys have it. But it's asking us to perform this division. So whatever this is on the bottom, synthetic division is the easiest way to do this. So if this is an x minus 8, you're going to put a +8 there. You're going to put this in a box. Then the next thing you want to do is you want to list the coefficients here. So if this is x squared, it's going to be a 1x squared minus 6x minus 16. So all I've done is whatever I'm dividing by, you do the opposite of whatever that number is. So if it's a -8, I'm putting +8. And then I'm going through and putting the coefficients of the problem. So 1x squared, -6x, and then -16. So when this is division, this is called synthetic division. We're going to move this 1 down, and we're going to say 1 times whatever is here. So 1 times 8, and that 8 is going to go right here. We're going to add -6 and 8 is 2. Take that 2, multiply it by 8, and that's going to go right here, which is 16. And -16 and +16 gives you 0. So this means this has a remainder of 0. And you're going to use the 1 and 2 to write the answer. So if it started with an x squared, you're going to go down 1 and just do x and then plus 2. That's what how you use the 1 and 2 to write your answer. If you started with an x squared, this is always going to be 1 less than that. So x to the first plus 2. And when we write our answer, we're just going to write x plus 2. We don't have a remainder there. Okay. If we want to factor this trinomial and state whether it is prime, we have a method to do that on the calculator that we've been using. If we've got p squared plus 3p minus 54, or we can, well, there's lots of different things we can do with this, but you're trying to think of, if you're just factoring it, what you want to know is, are there two numbers that multiply? Okay, we're looking for two numbers that multiply. There's nothing in the front here, so multiply to negative 54, but add to give me 3. And we did that, we kind of did that thing in the calculator where we cheated a little bit on this one to kind of aid us. So if I go to my calculator and I use that to kind of help me to find those two numbers that multiply to negative 54, we're just going to change this to negative 54 divided by x, and then negative 54 divided by x plus x. Okay, and we would look at the table, and we're looking at the table for the term in the middle, which was a positive 3, I do believe. So I do see negative 3 there. There's a positive 3 right here. And so the two numbers are 9 and negative 6. These 9 times negative 6 is negative 54. 9 plus negative 6 is 3. Those are the two numbers that's going to satisfy this. So I can factor this. It would be p plus 9. So I'm using that first number. And then p minus 6. There's the second number. Okay. On this one, we're looking for two numbers that multiply to give us negative 20 and add to give us negative 1. So this can be rewritten as x squared minus 1x minus 20. This one's kind of easy, so I could go to my calculator and do that same thing that we've been doing, but negative 4, no, it's going to be opposite. Positive 4 times negative 5 is negative 20, but 4 plus negative 5 is negative 1. So these are the two numbers that are going to work. So I would say x plus 4 times x minus 5. Okay. So on number 5, this one, to start off with, I'm noticing that in the squared part is in the back. So the first thing I would even do on this one is just kind of rearrange it and put the 2c squared in the front plus 11c plus 5. Now remember, this one is just a little bit different. If we're going to work this one, we want to take the 2 and multiply it by the 5. So 2 times 5 is 10. So we need to think of two numbers that multiply to 10 and add to 11, which is this term in the middle. So to use the calculator, and again, that one's not that bad either, right? We don't have to use the calculator. It's just 10. 10 times 1 is 10, but 10 plus 1 is 11. So these would be the two numbers that are going to work here. But then you're going to have to go back and make sure that you finish the problem by making sure that you divide out. So hold on one second. We do want to find those. So if I go to my calculator and I do can't just do it that way, sorry. So if we go to y equals and we type in 10 divided by x, and then 10 divided by, not times, divided by x plus x. Delete this one off. Okay, we want to look at our table. And remember that on our table, we were wanting it to add to be 11. So here's the 11, and here's 11 up here, and the two numbers are 10 and 1 on both of those. This one's just a little bit different because we have a number in the front. So when we start to write our answer, we're going to have to keep that in mind. We've got this number in the front. And this one was one that we probably would want to factor by grouping. So we could divide this up and say, well, 2c squared plus, now we would use this 10 and this 1, so we would divide this 11 into 10c plus 1c, and then we would have our plus 5, divide this up. So we would get 2c, we could factor out a 2c out of 2c squared and 10c. Well, that's going to get me, if I take 2c out of 2c squared, that's going to get me c. If I take 2c out of 10c, that's going to get me 5. And we're supposed to have that over here, and we already do. So there's already 1c plus 5, so we would just put plus 1. So our final answer would be 2c plus 1. That's coming from this stuff. And then the c plus 5. And you could write it in either order. You could say 2c plus 1 times c plus 5, or you could say c plus 5 times 2c plus 1. Okay. On this one, they've kind of got the first step done, and we just went over, this is in 5.8 where there's special rules, and when we're talking about something that is prime here, but they've already figured out that this is 2a plus 5b. Okay, so here's what we know so far. I'm just going to draw this box. We know that this is a 4a squared because it's written right here. This last term is negative 15b, and I already know that one of the sides is 2a and 5b. Okay, so after that, I can kind of problem solve. So if this is 2a, this has to be 2a because that's the only way I can get 4a squared, 2a times 2a. So this is 5b. So 5 times what's going to get me negative 15? Well, that's going to have to be a negative 3. Okay, and so, so this, that's going to have to be a b there also. So these two terms in the middle would end up being your 2a times negative 3b, which is negative 6ab, and then 5b times 2a is 10ab. So these two right here are supposed to add up to be 4. And 10 minus 6 does add up to be 4, so we're good. So 2a plus 5b, the other one's going to be 2a minus 3b, which is written right here at the top. And we just kind of brainstormed to figure out what the missing part was. Okay. It says write the following in factored form by factoring out the greatest factor. Okay, so we want to see if 17 and 64 have anything in common. And 17 is a prime number. 17 won't go into 64. And so on this problem, we can't factor anything out. There's not x's in both terms, so there's no common factor other than 1. 17 won't go into 64 an even amount of times. Okay, number 8 says factor the following expression completely. If the polynomial is prime, then state that as your answer. So I'm kind of looking at the 45 and the 80 first. I can already tell that 5 goes into both of them because one of them ends in a 5 and the other ends in a 0. So I want to see if anything bigger than that goes into them. So I'm just going to start thinking 6, the 6 go in there, 45, no, 7, no, 8, no, 9, yes. 9 will go into 45 5 times, but 9 won't go into 80. So I think that we're done when we're talking about, we're going to factor out a 5. So 5 will go into 45 9 times. I still have my x squared left. And 5 will go into 80 16 times. Okay. And we're done there because this is not a minus. This is not the difference of squares. So we can just put 5 times 9x squared plus 16. Okay. Again, they're wanting us to factor this trinomial completely. So we don't have anything that 5 and 11 and 2 have in common, but we can take our first term and multiply it by our last term. 5 times 2 is going to give me 10. So we're really looking for something that multiplies to give us 10, but adds to give us the middle term, which is 11. And we just did this. So the answer was 2 numbers that multiply to 10 and add to 11. Those 2 numbers are 10 and 1. Okay, so what you do is then you factor this by grouping. So you divide this up, 5x squared plus 10x plus 1x plus 2. Okay, so I've just taken this 11x in the middle and divided it into 10x and 1x. Factor out a 5 and an x. That's going to leave you with x plus 2 here. We already have x plus 2 over here, so that has to be a 1. So 5x plus 1 times x plus 2. Now number 11, they're wanting us to factor this completely. I'm noticing that there's an x in each term. And I'm also noticing there's a 2. Okay, and so if I take out a 2x out of 2x to the third, I still have x squared. If I take a 2 out of 8, that's a 4. And I'm taking one of the x's out of x squared, so I still have one left. And then 2 will go into 6 3 times. Okay, then I want to see, can I factor that? So I need something that, this one's not difficult. We need something that multiplies to be the last term. So multiplies to be 3, 2 numbers that multiply to give us 3, and add, same 2 numbers have to add to give us that middle term, which is 4. Okay, so something that multiplies to 3, how about 1 and 3? And if you add 1 and 3, you're going to get 4. So that's going to be x plus 1 times x plus 3. And that's what would go here, 2x. And it doesn't matter whether you say x plus 3 times x plus 1. Doesn't matter what order they're in. So there's problem number 11. And I'm going to post this video this afternoon. So it will be up for everybody. Okay. This is called the difference of squares. And when you take the square root of 25, it's 5. So that's how we know it's the difference of squares. When the problem is the difference of squares, it's super easy. All you have to do is put s minus whatever the square root of that number is, and then s plus whatever the square root of that number is. That's called the difference of squares. That works out nice like that. This one, if you'll notice, this is a little bit special too. When you take the square root of 25, you get 5. And when you do 5 times 2, or 2 of those, you're going to get 10, which is this middle term. Okay, when that happens, it ends up being that this is C plus 5 times C plus 5, which the shortcut of writing that would be C plus 5 squared. And that's what goes right here. Okay, on number 14, I'm noticing that there's an X in both of these, so I can take that X out. If I take an X out of X squared, that's going to leave me with X still. If I take an X out of negative 7X, that's going to leave me with minus 7. And then that's it. There's nothing else I can do with that. It's just X times X minus 7. Um, 15 2m to the third plus 14m squared minus 156m. What I'm noticing about this is there is at least 2 in all of these. There's also an m in all of those. So the first thing I want to do when I'm starting to factor this thing is I want to take that 2m out. If I take a 2m out of 2m to the third, I still have an m squared left. If I take 2m out of 14m squared, well, 14 divided by 2 is a positive 7. And then if I take an m out of m squared, I still have one of those m's. And if I negative 156 divided by 2, if I take a 2 out of that negative 156, we've got negative, I think 78. Let me check on my calculator. Negative 156 divided by 2. Yeah, negative 78. And if I take the m out, I won't have an m there. So at this point, you're looking for 2 numbers that multiply to give you the negative 78 and add to give you 7. Okay. This is probably one that I would go to my calculator and do and let y1 equal negative 78 divided by x and y2 equal negative 78 divided by x plus x, and then look for 7 in my table. So I'm going to do that real quick just to remind you and go to my calculator and show you how to do that. We go to y equals, got negative 78 divided by x. And then we've got negative 78 divided by x plus x. And I'm going to go second table. And I'm looking for a 7, I do believe, not negative 7. So let me back up, see if we have any. So there's 7 right there. So that means the 2 things that are going to work, 2 numbers are 13 and negative 6. So 13 times negative 6 is negative 78. 13 plus negative 6 is 7, sorry. 7, which is what I want. Because it's the middle term right here. Where we have right here. So m plus 13 and then m minus 6 would be the 2 options there. Number 16, again, we've got factor this completely. I think we can take a 3 out of 12 and negative 36 and 27. And the reason I know that is just practice, but you can always just guess, like try to start with 2 and see if 2 will work in all of them. See if 3 and keep going and see if there's anything that's bigger that will work. But there's something that 3 will definitely go into 12. And all of these have a y in them. So 12 divided by 3 would give me 4. If I take a y to the y out of y to the third, that's going to be y squared. And then negative 36 divided by 3 is going to be negative 12. I don't know why I'm putting 9. Yeah, negative 36 divided by 3 is negative 12. I still have one of the y's, so I took one of them out. And then 3 will go into 27 9 times, and I removed all the y's. Okay, this problem, 4y squared is actually a perfect square, and 9 is also a perfect square. So when you see this, and this one in the middle is a minus, it's going to be 2y minus whatever the square root of 9 is, which is 3. And the other way to write that would be 3y times 2y minus 3 squared, because I have 2 of those. Okay, and you could check it out and see if it works. You could also do like if this method is different, you could also do that completing the square method on that to solve that one. Here we go, complete by factoring. Well, they're already telling us one of our answers is x plus 3. So if we draw our box here, we know that this is x squared. We know that this is 3. We know that one of our answers is x plus 3. So to get x squared, if this is x, this has to be an x. To get 3, this would have to be a 1, because 3 times 1, right? So let's just see if the rest of it checks out. This would be 1 times x, which is 1x. This would be 3 times x, which is 3x. And these middle two terms need to add to be 4x. And they do. 3x and 1x is 4x. So we would get x plus 3 times whatever we got on the top, which is x plus 1. Okay, number 18, we're going to factor this completely. So again, this one's, I mean, you can always use your calculator to help you with this, but we're looking for, this one's kind of easy because there's no number in front of the b squared. So we're looking for two numbers that multiply to give us 3, but add to give us 2. Okay, so, I mean, that's probably impossible, because the only thing that's going to multiply, we could do 3 times 1 and get 3. They could both be negative, so negative 3 times negative 1 would give us 3, but neither one of those are going to add to give you 2. So this is that example is prime. It's just not going to work. They're wanting us to factor number 19 by grouping. So we could factor out m here, and that would leave us with 3 plus n if I took a m out of both of those. On the 15 and the 5n, I think I could take a 5 out of both of those. So that would leave me with 3 plus n. 15 divided by 5 would give me 3. 5n divided by 5 would just leave me with the n, which is what we need, because we know that we would get, combine and get 3 plus n. And then we would put the m in the 5, so m plus 5. Would go right there. And then our last problem, it says write in factored form by factoring out the greatest common factor or a negative common factor if the coefficient of the term of the greatest degree is negative. Okay, so and it is. So we're trying to factor out the largest thing we can. So both of them are negative, so I'm going to factor out a negative number. And I'm thinking, well, what's the biggest number that will go into 35 and 5? Well, it's 5. Okay, and then when you compare your variables, you got x to the 5th and x to the 4th, so you would want to factor out the smallest one of those. So negative 5 will go into negative 35. So what you would type in your calculator is negative 35 divided by negative 5, and you would get 7. If I take x to the 4th out of x to the 5th, I still have an x. Okay. Negative 5 divided by negative 5, that's going to give me positive 1. If I take x to the 4th out of x to the 4th, I wouldn't have any x's left. And so the final answer is just negative 5 x to the 4th times 7x plus 1. And so that is a test review for chapter 6.